We need to verify the following statement using vectors. The line segment joining the midpoints of the adjacent sides of a quadrilateral taken in order form a parallelogram. Okay, let's try to first understand with the help of a diagram. So here we have a quadrilateral. Well, let's call it A, B, C, D. So these are the vertices of the given quadrilateral. We will consider an origin O, and with respect to this particular origin O, we can define the position vector of these four vertices. So we'll assume that the vertices of A, B denoted by A vector, B is denoted by B vector, C is denoted by C vector, and D is denoted by D vector. Next, we will consider the midpoints of each of the sides. We'll start with the side AB. Let's consider the midpoint to be at point E. Then we'll go to the next side and the next adjacent side BC and consider F to be the midpoint of BC. Then we have G as the midpoint of CD and H as the midpoint of the side DA. Now that we have the midpoints E, F, G and H, we can also define the position vector of the point E. To define the position vector of the point B, we will be using the internal section formula, because here clearly E divides AB in the ratio 1:1 internally. So we can define the position vector of the point E as OE vector equals to A vector plus B vector divided by 2. Then similarly we can define the position vector of the remaining midpoint. So here we have OF vector. The OF vector will be equals to B vector plus C vector divided by 2. Then we have OG vector. So OG vector will be equals to C vector plus D vector whole divided by 2. Then we have OH vector. So OH vector will be equals to A vector plus D vector divided by 2. Fine. The whole idea of defining the position vectors of the midpoint is because in this problem we need to show that if we join the line segment joining the midpoint of the adjacent sides, that means if we join E and F, F and G, G and H and E, then the quadrilateral that's going to be formed is going to be a parallelogram. So that's what we need to show. So let's begin by first joining EF followed by FG, GH and HE. So here we have the quadrilateral EFGH. We need to show that this particular quadrilateral is actually a parallelogram. So all we have to do is show that the opposite sides are equal and parallel. Then it's going to be a parallelogram. Similarly, we can show that EH is parallel to GF as well as equal. Okay, to do that, all we have to do is first begin by finding out the vector EF. So here we're going to find out the vector EF going from E to F. So now EF vector. So EF vector is simply defined as take the position vector of point F and from here subtract the position vector of the point E. The OF vector, we have already defined it. It's B vector plus C vector whole divided by 2. And from here we're going to subtract OE vector. So that's A vector plus B vector whole divided by 2. Thus solving this we get C vector minus A vector over 2. This is our vector EF. Then we're going to define the vector HG. So going from H to G, so here we have HG vector and HG vector will be OG vector minus OH vector. The OG vector, that's C vector plus D vector whole divided by 2 minus we have OH, that's A vector plus D vector whole divided by 2. Now here when we combine them we get C vector minus E vector whole divided by 2. This is suggesting that EF vector that's equals to HG vector. Now EF vector equals to HG vector, that means since these two vectors are equal to each other, so that means magnitude wise they are going to be of equal length, and also since the two vectors are both going in the same direction, so we can say that EF and HG are also parallel to each other. So here we have showed that in the quadrilateral EFGH, the EF vector is equals to HG vector. Similarly, we can show that if we take let's say HE vector, that will be exactly equals to that of GF vector. So let's show that. Similarly, HE vector will be exactly equals to the vector GF. So from this two condition, we can now successfully say that thus EFGH, which is the quadrilateral formed by joining the midpoints of the adjacent sides of the main quadrilateral ABCD is a parallelogram, hence proved.